Alright, lots of stuff going on here. This is Moffat's example of analysis of a scatter plot assignment. So this will help people that are stuck on that assignment. I'm going to talk about the whole thing, even though so far in class I have not gone over that much, but I will do the whole thing. So here's my data. This is different than your data. First question is make a scatter plot on the axis provided. Remember tails, you can use the draw function and typing. So for your scatter plot, you can use the draw function and typing in the notebook. But mine, notice my beautiful title, called title. I have the x on the x-axis and the y on the y-axis. Don't mix those up. I also have a good scale. I went up by 2s. That's fine. This one went from 7 to 20. I didn't have to go down to 0. Like yours, I think starts at like 60 something. So you could start at 60 and go up. You just want even increments. So I said 5, 10, 15, 20. But I could have just started at 5 and just put 5 at the bottom, just said 5, 10, 15, 20, and it would have been just fine. I actually would maybe have even better use of space if I did that. I was just close enough to 0 where it didn't matter. I didn't ask you to do the describe your scatter plot, but remember direction, strength, form. So this is strong, positive, and linear is how I would describe that. Well, it's not part of your assignment, so I'm just going to do a nice little delete. Okay, so I said use the statistics calculator in Teams or the link below to find and interpret in context. So I gave you a link to this calendar, or to this statistics calculator, but also it's in our Teams app. So if I just go into our team, which is either 4th or 5th period, and then go to the top and go to statistics calculator, that will work. You can hit regression analysis, plug your numbers in there, then hit analyze. Oh, I'll put in some fake numbers. 1, 2, 3, 1, and 3. Okay. You analyze, and you'll start to see 3 things. You'll see coefficient of correlation. Mine for some reason is being dumb, but that's okay. You can always go to the website. That's almost easier. It'd be the coefficient of correlation. That's R. I always call it R. Coefficient of determination is R squared, and the least squares regression equation, or least squares regression line. So here's those 3, and I'm going to interpret all 3 in context for my example. So R is how strongly linear this stuff is. It's really close to 1, meaning it's very linear, and it's positive, meaning it's sloping upwards. So I could say the relationship between time and depth has a strongly linear correlation in the positive direction. R squared, I just changed my into a percent, and I said, okay, 94.28% of the variation in depth is because of its linear relationship with time. So I want whatever your x is, oh sorry, y is because of x, because it's independent dependent that way. So depth is y, time is x. So it's just how much of y is because of x. That's all it is. So you just copy this sentence, but with new percent and different variables. Interpreting slope and y-intercept. There's a whole slope video on this. I know, I'm going to post all these. I've made a million videos today. That's our slope, and that is our y-intercept. So to interpret the slope, it's every time x goes up 1, y goes up by this much. So again, I could specify every time 1 minute passes, that's our x. Every time x goes up 1, y goes up by this much. So as x goes up by 1, y goes up by this much. Or down, if it's negative. And then the y-intercept is at 0 minutes, you got the y-intercept. So at 0 minutes, the depth is 2.3. Okay, moving onwards. This one might be a slightly longer video, because this is kind of a long sound. Making a prediction. Use the least squares regression line to predict a depth after 2 minutes and 10 minutes. I asked you to make 2 different predictions with yours, so I'm doing 2 predictions with mine. So I plug 2 and 10, which are my values. You're going to have different ones, but into the least squares regression equation, and I got out 6 and 20.8. So then I said draw both predictions on the scatter plot in a different color and connect them with a line. So that means the points I'm going to need are the x, y. Plugged in an x, got out a y. So, and you should be saying y hat, not just y, because this is a predicted value, it's not an actual value. So, drawing both predictions in a different color. So I'll use these points. 2, 6 for that one, the first one, 10 and 20.8 from the second one. I'm going to draw them on here in a different color and connect the dots. So 2, 6, I mean, that's going to be right next to where that was, slightly below. Yellow's not a great color for this. Green, maybe. There we go. And then 10 and 20.8, so it's a little higher than that. So if you had a ruler, and I don't know how to make this ruler work, but if I did, I would use it. You can connect through the dots. Mine is not pretty because I didn't use a ruler. But if you make 2 predictions and connect the dots, you should be okay with that one. Okay, so that's where class ended so far, but I'm going to keep going. Find a residual for each point on the scatter plot. So residual is your y value, your actual y value, minus your predicted y value. So what a residual actually is it's a regular y. This is your actual y is here's 19 minus your predicted y. The predicted y is on the line. So it's a residual is this distance from the line to the dot. Each point has its own residual. So what I'm going to ask you to do is find the residual for each one. So you have to make a prediction at the same x as each point. So I have to make a prediction at 2, at 4, 6, 8, 10 for mine. And then you're going to take y and subtract it from that. So I did this, I just typed this up so it would help. I had my x and y's, so then I plugged each x in. You notice I plugged in 2, plugged in 4, 6, 8, 10, and I got an answer. That's the y hat, is right here. These guys. Those are all the y hats. And then that's not quite done. A residual is the y minus the y hat. So I did 7 minus 6 is 1. I did 8 minus 9.7. So it's always, I'll actually do this in a different color. It's the y's minus the y hat. So it's yellows minus greens. And that gets you what's called a residual. That gets you that little vertical distance on the graph, or on your scatter plot. So then what use do these things have? Well, it's nice to tell you how far off you are from predicted, like you maybe did way better than expected, or like, you know, maybe you would realize that this one sank less than expected, that one sank more than expected. You could look at individual points, but what you can also do is you can check to see linearity. So we're going to make a residual plot, and this is going to be graphing your x-axis. So I'm going to graph my x's, because normally you just graph x and y, but we're going to graph x and residuals. So I have to make an axis for my residuals. It looks like it only goes as low as -2. So what I'll probably do is I'll just probably go like, okay, that's 1, 2, -1, -2. It's a pretty good scale for me. And then we can start drawing points on our scale. So at 2, I got a residual of 1. At 4, I got a residual of -1. At 6, I got a residual of -4, -0.4. At 8, I got a residual of -1.9. And at 10, I got a residual of -8, -0.8. So, that seems really odd. Did I accidentally put a negative somewhere where I shouldn't have? 19 minus, oh yeah, this is a positive 1.9. Good job, Moffat. That's a positive 1.9. So I messed that one up, because I did a bigger number minus a smaller number and wrote negative. So ignore that. But Yeah, so I have my residual plot. This helps us answer the very last question. Based on the residual plot and R value, what does our data appear linear or nonlinear? Well, as we're going to talk about in class, a residual plot of just scatter, consistent scatter, like consistent scatter like that, that's actually shows linear. I would call this consistent scatter. It's too few points for me to really tell. The way you would tell if it's nonlinear is if you would get, I'll make the blue one nonlinear, is if your residual plot like curves. Then you could see if it's nonlinear. I'll draw the points better. So like if your residual plot curves in some way, that's nonlinear. You could also look out for other things in residual plot, but for now I just said linear or nonlinear. So mine, I would say, appears linear. If yours ends up with a random scatter, yours also would be linear. And then nonlinear if it's curvy. I mean, like an actual line is curvy, but sometimes looking at the actual scatter plot can be tough to tell. If I look at that, it's hard for me to tell if it's curving or not sometimes, if the points are close enough. So we look at a residual plot to see that. Okay, that was a long video. I appreciate you all, and hopefully this helps you.